Text, be it written or printed, is a visual manifestation of the language. And it's one of the primary ways we consume and communicate information as human beings. And everywhere humans go, they bring text with them. In our society, I would say reading is fundamental. And, well, computers and other smart devices are no exception. Quite the opposite, in fact. They are full of text and have been initially built to just render text. And now they do that, or they render emoji. And some people speak in emoji, so, well, it's still text.
It's quite appropriate.
Yeah.
Thumbs up.
And that's why text storage, layout, and rendering system are in the heart of many UI frameworks.
Is that revealed?
That's Revert, it's open source, don't worry. So, hello, my name is Vlas, but you can just call me :support:. And today, I'd like to talk about TextKit. Yeah?
Did you do the intro slide in TextKit?
No. Sorry. So TextKit is a high-level typographic framework that's built into UIKit since iOS 7 and AppKit since forever. But today I'll be covering the UIKit part, obviously, because duh, it's UIKit day. And well, not just because AppKit, like no one uses AppKit anymore, right? Haha. So TextKit acts as an abstraction layer between core text, that's Cocoa's foundational C-based API with a similar purpose, and text rendering views like UI text view. This is actually a picture from Apple's documentation, and it does state that UI text field and the UI label use TextKit, but it's a bit harder to prove that. But so let's just stay on UI text view. And a nice thing about TextKit is that, well, you're already using it indirectly when you add a text view to your app. But it actually allows you much more. You may remember that before iOS 7, UI text view was actually was basically a web view, at least partially. It was translating the strings and attributes strings that you then to it into HTML and, well, rendering it using WebKit. And this is why I find it so great that since iOS 7, we can actually use a fully native API to do things with text. So TextKit, for example, with TextKit, you can use the built-in implementation of text layout and processing that's used in the system offline without actually creating any text rendering views. You can even potentially do it off the main thread. What a blasphemy. Many things that we had to do using core text C APIs before iOS 7 are available in TextKit. And it provides a slightly more approachable interface. And you can also customize text layout and rendering in your text views. That's because UI text view exposes TextKit objects that it uses and even allows you to specify your own. So for example, you can create a text view instance by vending it your TextKit stack, basically. Now, my goal today is actually to give you a little bit of information about TextKit and some examples of what it makes possible so that next time you're looking for some typography-related functionality, you know where to start. And for this reason, I'll cover several examples, some of them being the ones I've used in the wild myself and which inspired me to do this talk. Here are some screenshots from an updated version of this app I previously was talking here about, called Fearless Little. A recent update has added inline photo attachments. So here, this is a collection view cell, and this is a text view inside that cell. And this is actually not even an image, it's a full-blown view inside the text. It uses manual truncation, some custom truncation mechanisms, and this is also a view inside your text, so everything is like inline. And some of that I will cover in a few minutes. So examples that we will look through are text column layout and exclusion paths, geometry querying and line counting, manual text truncation, and text attachments. Now, before we actually start with these examples, I would like to give a little background to make sure we're on the same page in terms of typography terms. Really quickly. So, you might know what's character. So the character is basically a Unicode point in a string. It can be precomposed, may not be precomposed, doesn't really matter. Now, glyph is an elemental graphical unit in the font. So here, for example, I'm showing two characters F and I stored in a string, while in many fonts, Fi is actually a so-called ligature, which is printed or rendered as a single graphical unit. That's because historically these printed letters had these. Sorry, what?
When I see the picture of the.
Oh yeah. It's just that people wanted to print things nicely, and so they invented ligatures as a way to basically customize the way that letters are being printed. Oh, and don't ask me about kerning. Now, line fragment, and this is a term used specifically in TextKit. It's a portion of a text line filled with glyphs. Now, I say it's called fragment for a reason. That is because theoretically, in certain situations, there could be more than one line fragment in a single line, and that is because of exclusion paths. But I'll show that later. Now, line break is line break is. I didn't prepare the presenter notes for that. Line break is either a hard line break, which is a carriage return, a line feed character inside your text, or also even a paragraph break character. There are quite a few characters that actually create line breaks, hard line breaks. Or it can be a soft line break, which is generated by word or character wrapping. Like on this little picture, you see that these are all soft wraps. There are no carriage return characters between words do and the next one. That's obviously lorem ipsum. Now, wrapping is automatic internal reflowing of text to the next line. And in certain cases, if you enable that, soft line breaks can actually be hyphenated. Like here you can see that this soft line break has been hyphenated and the word is broken in two parts. Truncation is hiding parts of text, usually at the end, at the start, or in the middle. I think the trail truncation is the most popular one. And replacing all the removed parts with an ellipsis. Now, here's a little note. A common misconception is that ellipsis is 3 dots. No. Ellipsis is a special character. It's a special Unicode character which you can either put in your string as a Unicode code point, or you can just hit, I think, Command semicolon, and that will just put in a ellipsis character in your string. The reason for it is, when truncation is generated automatically, it's the ellipsis character that's being rendered and inserted, not 3 dots. And you might see, like, this is a simulation, but whoops, I didn't do it. And
you don't have a new touch bar MacBook Pro, do you?
What the?
Yes. No, he's not.
No, he doesn't.
Okay.
Who do you call for help and support?
Yeah, I know. So what happened? Just
Backup support.
Yeah,
we open
I'll go
Windows,
back to this
jump.
place.
Maybe you call level 2 support.
That's where it is.
Level 2 is
not
Jesse.
boardroom.
I have no idea what's going on. Then we reach out to Bog.
technical problems.
Who will just suggest using arrow train.
Yeah. Jump in the tram and get far away.
Okay. For some reason, it has just disconnected. Okay, let's go back to.
Outline Microsoft.
So yeah, basically, it's just it's a error that I've seen in a few places across the years that people just say, oh, that's just 3 dots in strings, and also when they perform custom truncation, which is even worse. And finally, paragraph is basically a block of text that's separated by hard line breaks or text boundaries.
What about Ruby?
What do you mean?
As in, there is this term called Ruby in typography, which is the hiragana, so the hiragana or katakana representation on top of a kanji character.
Right. I'm not sure TextKit supports that, and
It does. It's
Oh,
actually
all right.
a core text
Right.
call.
Okay. Well, unfortunately, I haven't been
Text string.
investigating into non-Western languages. Yeah, sorry about it.
You get interested in Russian?
Yeah, sure. I mean, duh. There's also this beautiful picture from Apple documentation. It's one of my favorites, really. It's related to fonts. It has all these different metrics of fonts and how they're called. But today I won't really actually bore you with these details because we don't actually need them right now, and you can look them up later. I will give a link at the end. Maybe just 2 really terms that we might need is the baseline and line height. And, that's mostly...
Remember the size of UI labels to account for the descender and ascenders.
Well, duh.
Yeah.
Anyway. Now, again, a little bit more background, but now closer to actual Cocoa APIs. Now, advanced text formatting has been available since iOS 3.2 in a form of attributed strings, as you might know. So it all begins with an NS string, obviously, and it contains all those Unicode characters, not necessarily composed ones, encoded as UTF-16 in the case of Objective-C NS string. I won't be talking specifically about Swift here, because of reasons. But yeah, in NS string it was encoded at UTF-16. Now, that is being wrapped by NS attributed string, but the magic of it is actually in the attributes dictionary that's associated with character ranges of a string. Now, attributes dictionary, which you can specify for any ranges of text, contain information such as fonts and colors, like background or foreground, underline color, stuff like that, links and shadows, etc. They all stored under specific keys in those dictionary. So, for example, if you want to specify the font of a range of characters, you specify that using a key NS font attribute name, and so on. NS foreground color, NS background color, NS link attribute name, so on. One special attribute is a paragraph style that's described as a NS paragraph style instance. It contains a multitude of different layout modes and metrics for each paragraph, including line height, like minimum line height, maximum line height, different things, including also alignment mode and line break mode. These are quite important. And this is basically how you describe text. Oh yeah, layout metrics. Now, you take that and put it in a TextKit stack, right? So TextKit contains, TextKit has several actors, as I call them, which is like core classes that comprise a TextKit stack. it starts off with an NS text storage object. That is basically a mutable attributed string with some extra smarts for track changes to it, including character changes and attribute changes. Now, TextKit storage may have one or more NS layout managers connected to it. Layout manager, as the name suggests, handles layout of text described in the text storage. So yeah, you might actually have more than one layout manager. I'll cover that a bit later. Now, layout manager fills the geometry that layout manager fills with the text described in the text storage is described by one or more, again, text container object connected to it. So text container may have a size, it may have exclusion paths, stuff like that. Now, as I mentioned before, UI text you can be initialized with a text container, and it basically describes a single page of content. And through back references from text container to layout manager and to text storage, the text you can access both layout manager and text storage is associated with. And the fun stuff about TextKit is that not only text storage and layout manager have delegate protocols that you can just connect via delegate property, but you can also, if you really want to, you can create your subclasses of either of these classes. I think the text storage is kind of harder to subclass. And you can override certain methods and implement your custom behaviors if you really want to. And again, vend those custom objects to your text view. So you don't actually have to re-implement the rendering if you only want to implement custom, say, text truncation. Yeah, each layout manager can have one or more than one text container. And again, I will show that in just a second because it's demo time.
Yay!
Okay, so now I will need to set up mirroring.
What's your background there?
Ah, crap.
Is it like a new gunship apple?
I think it's...
That's more gunship.
I know, right?
Thank you, Jinju.
That was actually Matt.
Yeah. That's the gunship guy.
Okay, let's... awesome. I don't really like this rendering, but so I will just...
Presenter mode, please.
Absolutely. Okay, where
Awesome
is...
colours.
Yeah, I haven't used that for a while.
Presentation mode.
Can you see that?
Large.
Okay.
Oh, yeah.
All right. Okay.
That's what I was back.
And I mean, I wish I could make the.
We'll
How-
take your word for it.
how-
that the text is a reasonable size.
Oh, I can.
Yeah.
Oh, all right. That works. That's nice. Okay. So the first example is probably the easiest one. So as you've seen on the slide with TextKit stack, you can have more than one layout manager connected to a single text storage. So that means you can have a single text, like attribute a string, and you can not only you can render that, you can lay it out in a different way, even simultaneously. So in this example, I have a lorem ipsum, and I have two text containers, and I have two layout managers. The stack is connected in a way that each text container has its own layout manager, and both layout managers are connected to a single text storage, a shared text storage right here. So I create two text views. Each text view uses its own text container, and thanks to the width, height tracks text views, the text containers are sized automatically. And I just put them in a stack view and put some change the text container inset so that it looks pretty, and that's about it. And so the result I'm getting is kind of weird. And by the way, if you didn't know, Playground Live View is actually basically just a iPad simulator. And Xcode just kind of crops the screen of the simulator and shows it here. That's why it's a bit flaky. And that's why you can see the part of the keyboard. Anyway, so the interesting effect is that as I'm editing one text view, the other one just is being edited automatically. There's no custom code there. It's just being updated automatically, simply because text storage emits notifications to all its layout managers. So layout managers are informed when characters or attributes change, and thus layout managers relay out all the text and present it to the text view, basically. Okay, that's kind of simple. Where would you use that? I don't know, not sure. It's more of a demo that you can have. Maybe, yes, maybe, but the problem is that because the text storage is actually shared, you cannot just tell each layout manager to render things differently. You can only lay them out differently, but the actual characters and attributes would actually be the same. So that example is of limited usefulness, and that's why I didn't include it in the first list. Now let's actually go to columns and exclusion paths example. And this one is actually one of the TextKit's kind of tentpole features that were demoed at DubDub. It says launching simulator.
Yay!
Have you seen it crash where you
Oh,
close
there
the
we go.
window and then you actually physically see the iPad
Oh, yeah.
and you can't interact with it?
Oh, so it didn't actually go away?
Mm.
Ew. Right. So this one is a bit different. Here I'm still using two text containers, but they're both connected to a single layout manager. And this means that the layout manager will use both of these containers to actually flow text between them. And this allows you to implement multi-column layout or multi-page layout. Each text view, as I said before, basically acts as a single page of content. And the text container it kind of represents that text view's geometry. And here in the middle you have this circle, and you can see how the text actually flows around the circle. And just to kind of visualize the idea even better, you can just drag it around and see how the text updates live. What I'm doing here to implement this updating, live updating, is simply I'm updating the exclusion paths in each text container, and that's it, because that invalidates text layout, obviously. In the code, again, along lorem ipsum, I create two text containers. Each one has this line fragment padding. That's just so that it looks better. I create a single layout manager. I specify the hyphenation factor because I really want the nice hyphenation. FYI, by default, hyphenation is off. The reason for that is because hyphenation is more, wrapping text with hyphenation enabled is more performance, is more CPU and memory heavy than wrapping it without it. But if you really want that, you can enable it easily. And you can actually do that even via a special attribute in the attributed string. But here I'm just specifying that on the layout manager. Single text storage, two text views, each initialized with its own container. Oh, by the way, if you're worried, this playground is already on GitHub, so you can all see the code later. Now, I have disabled scrolling on both text views. The reason for that is because if the scrolling is actually enabled, the text will not flow to the second page. That's probably because, in this case, the text container for the first text view will be automatically sized to the size of the text, and the text view will be just scrollable. But here I'm saying, hey, I want you to make the text container have the size of your bounds and not have you scrollable, so that layout manager knows that the text needs to flow on the next text container. Again, just stack view. Now this, I have like a shape view that has a gesture recognizer, and it can render a shape path. And this block I'm calling path updater, it just takes the UI Bezier path for the shape and translates that between two text containers so that each text container has its own copy of the path in its exclusion paths array that reflects the frame of the text view that represents that text container. So these two text views do not actually share some sort of a coordinate system. Each has its own, so I have to translate those exclusion paths. One important thing to mention here is that text containers actually have a separate coordinate system from the text view. And this is, which is why it's important to convert coordinates between two when you have to cross the line between UI view hierarchy, and UI text view being part of that, and TextKit's text container. The mismatch of the coordinate system is mostly represented by really? I didn't put it here? Sure I did. It's on a previous slide. The mismatch is represented by the, I think it's called text container insets. It's a property on UI text view, and it tells the text view to inset the actual text container inside its own bounds. And by default, I think the insets are 8, 8 top and bottom, and 0 on the left and right. Because the insets that you see by default on text views on left and right are actually generated, interestingly, by a different property that's on a text container. And it's called line fragment padding. Go figure. It's important to remember these things when, for example, you want to have a text view, a static text view that just renders your text without any paddings. In this case, you'll need to put zeros both in line fragment padding and in text container insets. Otherwise, you'll get either top and bottom paddings or left and right paddings. And yeah, gesture recognizer drives a change to the circle, and the paths are being updated. Yep.
So the library is open.
Okay.
What you mentioned, you using NS attributed string. So what would be a common use case for, apart from rendering lorem ipsum with the Japanese flag in the middle of the screen, but like what would be a common use case where we should realistically use TextKit instead of just NS attributed string?
So NS attributed string is a storage for text characters and attributes. TextKit is a framework that lays them out and renders them. You probably already use NS attribute string in different places, but don't interact with TextKit directly. For example, if you want to add a different font to a part of the text, like you might want to say, make part of the text bold, or you want to put a link on a part of your text. You're probably creating an attributed string out of your original string, and you set a special set a special dictionary of attributes to a substring, right? And you probably put that in a text view, right? With TextKit, and that's certainly not the final example here, so you might see better examples of how you can use that. TextKit allows you to customize the layout of your text, and also text wrapping, and enables you to do things like this.
So would you say to use TextKit wherever possible?
I wouldn't. Again, with any kind of tool, it's really important to use the right tool for the occasion, and it's more about situations where the default layout, the default tools you have with UI text view, for example, just do not suffice. And I'll show you more examples in a few minutes, and you might get a better idea of what these situations are, really. Okay, yeah, I understand that this example is probably not something you would have to use every single day, and that is why example 3, geometry querying. So here we have again, a single text view with a large lorem ipsum with customized fonts. Zapfino, being a very weird font, is used here. And there's this overlay that renders this kind of wireframe. It has 3 modes. One renders line bounds, another one renders character bounds, or the glyph bounds actually, and the third one renders bounds for a substring. So why would you use that? Well, maybe for example you want to render something on top of the part of your text. For example, I'm pretty sure that iOS standard text highlight uses something similar because it needs to know what are the bounds of the text you have highlighted or selected, rather. And here you can see how this overlay renders something similar. So the way it is done is, so we have a static text view, some fancier fonts. This text painter thing is just this overlay that queries the layout manager for text geometry and renders the overlay as a shape. Oh wait, sorry, text painter. That's text wireframe overlay. Text painter is this other thing I tried here. Is you can kind of just paint over text using a pen gesture recognizer. What it does is, as you pan through the text view, it queries the layout manager for the bounds of the character you touched, and it sets background color for these characters. A use case for that could be in real scenarios. For example, you want to know what character have you touched. Maybe you have custom link handling, or you want to have your own text editor. Sorry?
Custom highlighting or something.
Stuff like that.
Direct highlight.
Yes. The trick with highlighting is in this text painter, I think. And obviously it gave me a generated header. Obviously that's what I want. Sources, text painter. It uses a gesture recognizer, and this category method is the main magic. So we have a point from the view hierarchy. We convert that to the text container, and this little method I put in there. Okay. It's pretty simple. It just uses text container insets and either increases, insets. Right, it offsets the points by text container insets. Nothing too magical. And it didn't put me in the right place. We convert the coordinates. We ask the layout manager, what's the character index for this point? That's it. And we get the character index, and we set an attribute on that particular character index. This wireframe overlay is a bit more complicated. So what you can do with Layout Manager is what am I looking for? Ah, yes, looking for this. You can enumerate your line fragments. You can retrieve range of glyphs that comprise each line fragment. So the layout manager will call the block for each line fragment in your text. You can also ask the layout manager for bounding rect of a specific glyph. Here I'm just enumerating all glyphs from 0 to the end of the text, and remember that glyphs and characters are not the same thing. Yep.
How does this perform in terms of scrolling?
This one is probably not the best way to do this, and especially because with fonts like Subfino, the glyph is actually, some glyphs, many glyphs, because Subfino, are rendered outside of the bounding rect of the glyph. So you have the bounding rect of the glyph, but the actual representation, the visual representation of the glyph from the font is rendered outside of it. It's a weird font. Unfortunately, to retrieve information like the actual metrics of the font, I think you have to drop down to core text, which I didn't want to go in there. And in terms of performance, well, maybe not for each glyph in the string. TextKit is optimized heavily, so if you just want to know a character or glyph number for a position, that'd be quick, fast. Or if you want to ask bounding rect for a few glyphs, that will also be really fast, because once the layout manager lays out the whole text, or in cases of non-contiguous layout parts of that text, it just caches all that information and invalidates that as necessary. So these queries will be fast. Finally, with the highlighted range, there is a method called enumerate and closing rects, which calls the block for every rectangular area that covers the range of glyphs that you have asked for. So as a result, if I just put the timeline back, oh, cool. So you'll get 3 calls, 1, 2, 3. Again, contiguous rectangular areas is what you get. Right. There are many more layout queries you can make from on Layout Manager. These are just a few. And I think at this point I should have maybe talked a bit more how you can use that in a real situation. The way I use it in my own code is, as you may remember from the slides, there were these screenshots with attachments, and I'll show you some stuff about attachments later. But in order to insert an actual view inside text, I need to know what should be the bounds of that view, right? And because I have an attachment there, but that attachment is empty, Layout Manager can actually, it allows me to query the layout bounds of that attachment. And so I query for that and then put a view with that frame in, basically. I'm not sure if, oh yeah, that library is closed permanently. No, it's open source. Okay. I think this example may be the most down to earth, let's say, and this is manual truncation. So I'm not sure if you have encountered at some point a situation where you want to render multi-line text, or even a single line text, really, but you cannot use the automatic truncation that's given to you by UI label or UI text to you. And so you kind of want to truncate the text manually, maybe? And there are dozens of wrong ways to do that. Obviously, the worst one is you just say, yeah, this kind of feels like it'll only fit 30 characters. Yeah, maybe not if the text contains of I, and so on. Or just really wide characters, on the other hand. This is not technically correct. The other way I have seen myself is using the standard method for calculating the bounds of the text, bounding rect and everything on NS attribute string. You calculate the size of the text and just remove characters on the end of the string one by one until the string finally fits the height you need. That's a bit non-performant to my tastes. So the way I kind of approach this and realize how it is possible with TextKit is by actually using the implementation of truncation inside TextKit, but without creating text views for it. If you just need truncation and text view, you can text views, you can just specify where is it? Or is it? Not here. Anyway, there is a maximum number of lines on a text container, and if you just grab the text container from a text view and set that maximum number of lines, you will get the standard truncation. But if you need offline truncation, you need to create an offline TextKit stack. So here, again, a lorem ipsum, 2 text views. One is non-truncated, just to show what are the bounds of the full text. The other one is also not truncated, but characters, the text in the right text view is actually generated manually. And so the result I'm getting is, let's delete this code, and that's the selection I was talking about. Hello. Okay. I don't know why backspace didn't work. Oh. Okay, I'll just do it like this. There we go. I think keyboard input has disappeared. Oh, now it works. Yeah, you can see how the truncation is being updated as I remove characters. And once the whole screen fits, there's more text that's appended to the truncated string will disappear. And boom, it's off. All right, now the way you can do this, and this is just, it's all just wiring of things. The interesting part is here. And again, I have to do that manually. This. Some guards, like obviously you don't want to truncate empty text, and you don't want to truncate manually if you have requested number of lines of 0. So you can create text container, which matches the bounds of the text view you will present the text in. Like for example, in this case, you want to know the width of the text container, but you can leave the height to, well, CGFloat max, which is in Swift, it's CGFloat greatest finite magnitude. You have to make sure that you copy the line fragment padding from the real text view, otherwise the width, the effective width will not match. You need to specify the line break mode. Usually it's truncate tail. Sometimes this particular method is for tail truncation. And you want to specify maximum number of lines so that Layout Manager will actually enable truncation. You create Layout Manager, add the text container into it, you create your text storage with the string you want to truncate, and you add Layout Manager to that. And this is the most interesting part. The main idea here is that you just basically go through line fragments one by one using Layout Manager line fragment rect for glyph at. This gives you glyph ranges for each line, also rectangles, but we don't need them here. And you just go through each of them until this other method, truncated glyph range in line fragment for glyph at, gives you something that's not NS not found. Objective-C APIs, NS not found, yeah. Once you do that, or once you manually reach the number of lines you requested, and that's kind of an edge case here, you can just say, oh, okay, this is the character that has been, or sorry, the glyph, the first glyph that has been truncated out. Once you find that, you can just truncate the string manually on that glyph and add an ellipsis manually. This is the code point 2026 for the ellipsis. And in this case, I'm just grabbing the attributes for the ellipsis from the last non-truncated character in the original string. There is this little edge case. If the last character of the truncated string is a line break, you also should remove that. It's a bit weird. And this. Okay, I have one more example, and that's it. It's actually pretty quick. And yeah, I'm adding this. There is more manually with blue text if text actually has been truncated. Now the final example.
Text to text view, right?
Sorry, what?
So you're adding that text to text view, you're putting the ellipsis in, and then you're putting more text underneath it.
Yeah. It's it assumes that the actual text you put the truncated text in will not actually truncate the text for you itself. That's why it's manual, right? Now the final example, and I will try to be quick with it, is text attachments. So if you didn't know, starting from iOS 7, you can put images in your text views, and that's implemented using text attachments. There is a class called NSTextAttachment, and you can initialize that. I think that's probably a custom initialize I put in via category. You can specify an image you want to render in the attachment, and you just put that NSTextAttachment as a value for NS attachment attribute name in the attributes of your string. I had to use like custom category methods here just because otherwise Playgrounds will crash because it will try to serialize the attachment and deserialize on Mac OS and it just will not work. And so here you might see that I put a little troll face, and this is a text attachment. It's a Lena with a paragraph style of center alignment, and so text view actually put the attachment on the next line because that's I did that. I had to put that on a separate line because otherwise the paragraph style would not be applied because there are no line breaks there, no hard line breaks, so it's not a different paragraph. And obviously that means that you can, put custom smileys in your text or custom icons in your text without actually using the icon fonts or stuff like that. You can just put in images right in the text view. And I'm pretty sure that labels can also allow you to do that. Probably because labels are actually rendered using TextKit. And this all also works if you want to calculate the bounds of your string. The size of the attachments will obviously be included in the overall size of your text. And that was the final example. I think. Okay. Just if you want references, there is documentation. There are two dubbed up videos from 2013, which are really good. There is a tutorial on Objective.io back from iOS 7 times. And you can find these slides in my GitHub. And the library I was referring to previously that allows you to put views as attachments in your text views, which is kind of weird, but it works. Questions?